Okay, hello. So I'm so sorry that this video came in a little late. I was having tech issues. Every time I would record, my voice wouldn't record, but this is our chance to finally get this in. Okay, so I finally fixed it and it should be able to work now. All right, so I'm just going to really fast in this area because we did this in class, but what you want to go ahead is title your notes, Unit 3.42, Graphing Quadratics and Linear Graphs. Now, example 1a says, complete the table below. Find smart values of x, then plot the graph with at least 7 points. Okay, so in this video, I'm not going to plot all 7, but I do expect you to have that in your homework. Speaking of your homework, you are expected to not only find the table points for a quadratic, but you also had to find a table of x and y coordinate points for a linear graph as well. So I'm going to explain what smart values are in a moment for those of us that were not present on Thursday, but I'm going to go ahead and start here with our first steps, right? So here our first step is to factor this quadratic, and we can do that by taking out the negative, and that's just going to change the signs of our quadratic here. And so then we'll get y equals negative x squared plus 2x minus 8, which then further simplifies to 4 and 2 plus 4 and minus 2. And then we have to find the zeros, so we're going to set this equal to 0. And then we'll get x is equal to 2 and x is equal to negative 4. All right, so the whole point of this is finding the roots are so we can graph that and we can see that, okay. So we can graph the roots already. So we can find 1, 2, 3, 4. This is negative 4. So negative 4, 0. And then positive 2, 0. Those are our roots. The second step, what I talked about in my video, or not in video, but in class, we said we need to use the vertex formula, which is x equals negative b over 2a. And we can find out what our a and b values based on our original quadratic in standard form. So we can see here, this is like a negative, but really that's like a negative 1 in front of the x squared. So we know a is equal to negative 1. And b is negative 2, so b is negative 2. And then c is a positive 8. So c is equal to positive 8. All right, so then all we have to do is substitute those into our vertex formula. And remembering that our vertex formula will be the x-axis as well. I mean, not the x-axis, the axis of symmetry. So here we'll have negative 2, or here, this should be negative 2. And then a is negative 1. All right, and then that will give us, this will give us positive 2 over negative 2, and we'll get negative 1. So x would equal negative 1. And all this represents is the axis of symmetry and also the x coordinate of the vertex. So here we'll find negative 1, x equals negative 1 right here, and we'll just go ahead and create some dash marks like so. And so we recognize that's our axis of symmetry, x equals negative 1. All right, so then at that point we can do step 3, which is actually finding some smart values. And the way you can do that is by this table is a little different from class. Essentially, if this section would go in the middle of x and y, but we would use the factored form of our quadratic to help us answer this. So I'm going to place that right in here. So we'll have the factored form is negative x minus 2 times x plus 4, right? And so then I'll do the first example, and this brings us back to finding the smart values of x. So all that really means is once we find the x coordinate of the vertex, in this case it's negative 1, we're just going to start at negative 1 because that's basically where either the maximum or minimum is going to start. And then we're going to pick some values that are greater than negative 1 and then less than. That's all smart values are. So here in this case, we'll say negative 2, negative 3, negative 4, and then here we'll have 0, 1, 2, and 3. That's all you're doing when you're picking smart values. So again, you start by finding the x-coordinate of the vertex and then picking numbers that are larger than that, and then picking numbers that are smaller than that. And then I'll just do the first example. So once you substitute, so if I were to show my work here, we have negative x minus 2, x plus 4. If I were to go ahead and kind of show what we did in class and saying that my first value is -1 in this case, then I would substitute -1 in the vertex form. And then when I calculate this, it'll end up being y is equal to 9. So then we'll find our vertex. So when x is -1, y is positive 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we'll have -1, 9, right? And then at this point, you can like pick, again, like -2 and calculate that. Sorry, my graphs are not exactly the same, but once you go ahead and do that, you'll do like -2 minus 2 and then -2 plus 4, and that will equal 8. So then your next point would be -2 and then 8, right? And then you would do the same thing, moving on with 0, for instance, plus 4, and that will equal positive 8 as well. So when x is 0, at y is 8. So then at that point, you would have 7 points. I'm just plotting 4 for the sake of time, and then you would go ahead and connect your points to best match your quadratic, okay? And then here, this is where you have a linear function. All I would like for you to do, essentially, whatever the x values you selected for the quadratic, you can just go ahead and select the same points. And when you do that, you'll recognize that maybe some points are somewhat similar, maybe not, but then we can go ahead and graph this also by just looking at the y-intercept. So finding positive 4, 1, 2, 3, 4, and then our slope is 1, so we'll rise 1, right 1, rise 1, right 1, and so on. And then you'll eventually realize that your line looks like this, and then you'll connect the dots, and that's all you really need to do there. Okay, so the second piece is the key piece that I want you all to recognize. So right here it says, use the substitution method to find the solution of the quadratic. So the quadratic that we have back up here, which is y is equal to negative x squared minus 2x plus 8. Minus 2x plus 8. And the linear function in number 3a. Well, this should say example 1a, but the linear function, which is y is equal to x plus 4. All right, so all we're going to do here, this is the new piece that I kind of want you all to recognize, is that we can set this up as a systems of equation. Even though they are not two lines, we have one a quadratic and the other a linear function. So what we're going to do is we can find a solution between these two algebraically. Okay, and we can do that by substitution. Now, we're going to do the same process that we've done in class before, where if y is equal to x plus, if y is equal to x plus 4, then we can substitute that y in to the first one. Okay, so that's what we're going to do right now. So here I would say that this is x plus 4 is substituted in for the y, which equals negative x squared minus 2x plus 8. And we can go ahead and solve for x, right? So here we want to get one side equal to 0, so I'm going to subtract x on both sides. And so then I'll get 4 is equal to negative x squared minus 3x plus 8, and then go ahead and subtract 4 on both sides as well, because we want to get one side equal to 0. So we get 0 equals negative x squared minus 3x plus 4, right? And so again, we're going to be problem solvers. We can solve for x here because we need to do box method, but I'm going to do this one in my head, and my first step is to factor out the negative. So I have an x squared plus 3x minus 4, and then I go ahead and factor this trinomial. So 0 equals negative x, and then we'll get minus 1 and plus 4. And so at that point, I'll get two x values. I'll get x is equal to 1 as well as x is equal to negative 4. Now, we didn't do anything wrong. Before, when we use substitution with systems of linear equations, you only got one x value, right? And then you're like, oh, okay, now I have to find the y value, substitute this in to one of the originals. Well, we're going to do that, but 2 times, right? We're going to do one for x equals 1 and another for x minus 4. So if I were to say first and second equation, the second equation is a lot easier to substitute our x values in. So I'm going to write this one more time, y equals x plus 4, and then y equals x plus 4. So when x is 1, or positive 1, when x is 1, I'm going to substitute that in. So here we'll have y is equal to 1 plus 4, and we'll get y is equal to 5. And then here we can do the same thing. When x is equal to negative 4, then I can go ahead and substitute that in as well. And let's say that this is 4. And then we have negative 4, and then we'll recognize that y would equal 0. So all this means is we have a solution at 1, 5, and negative 4, 0. Okay, so essentially what we're going to eventually move into the next class is having us solve algebraically, finding a solution of different functions, right? So like in Algebra 1, you did a line and a line, linear functions and linear functions, right? But we're going into directions where we could have a quadratic and a line, right? Parabola and a line, or maybe a quadratic and a quadratic, but that's a little more complex and we probably won't get to that, but that is possible if you're thinking about that. So we can find different solutions algebraically. And then here where it says like what you notice in your homework, I would like for you all to think about how is this similar to solving for a linear equation, and how is it different? Or not equation, but linear system, and how is that different? And also maybe thinking about, after you've graphed these, like where are these points located, right? Like where are they located in terms of the quadratic and the line, okay? So that's it. So go ahead and write your summary. Again, if you have any questions during your summary, feel free to write that. Some of you all are really good at writing those sticky notes and checking in. I really like that you all are doing that because it helps me understand where I can start you off in class. So keep that up and good luck. Alrighty, bye.